One.
So it just has one, and so does chromium.
Okay.
So sodium, what's the atomic number?
11.
11.
Mm-hmm.
So we have 1s2, 2s2, 2p6, 3s, 1. The highest coefficient is 3. So this is our third energy level. How many valence electrons? 1. You can see sodium is in that first column. Just kind of a proof of principle. Let's do potassium. What's potassium's atomic number?
19.
19. So we have 1s2, 2s2, 2p6, 3s2, 3p6. This gives us 2, 4, 10, 12, 18. We need one more. 4s1. The highest coefficient is 4. Number of valence electrons is 1. And they're both in that same first column. If you looked at magnesium, magnesium's atomic number is 12. How many, just based on the columns, what would you expect it to have?
2.
One more than Na.
Right. So we have 1s2, 2s2, 2p6, 3s2. Our highest coefficient is 3. The number of electrons is 2. So let's look at one that's in the 5th column and the 7th column. Let's try nitrogen, and let's do chlorine. Atomic number for nitrogen? 7. So we have 1s2, 2s2. We've used 4, so we have 3 left. 2p 3. The highest energy level is 2. So it's going to encompass both the S and the P.
So it's going to have 5 valence.
So you got 2 and 3, which makes 5. So we have 5 valence electrons. And if you count the columns excluding that transition metal, you can see it's in that 5th column. Chlorine's atomic number is
17.
17. Based on the columns, what would you predict it to have?
9.
7.
7?
7, yeah. 7.
7 valence electrons?
Mm-hmm.
So let's use up 17. So we have 1s2, 2s2, 2p6, 3s2, 3p, and how many are left? 5. Our highest coefficient is what? 3. And we have a 2 and a 5, which gives us 7. So that one has 7 valence electrons. Copper?
Yes.
So do you know the difference between electron configurations and electron orbital diagrams? The orbital diagrams is where you draw the boxes. The electron configurations is where you have 1s, 2s, and so forth. So the first thing that was asked is electron configuration for copper. The abbreviation is Cu. The atomic number for copper is what?
29.
29?
Yes.
Okay. So the atomic number is 29. The atomic number means the number of protons. So we have 29 protons. And then assuming it's neutral, we have 29 electrons. So we begin with the first energy level, which holds a maximum of 2 electrons, and you have an S sublevel. So we have 1s, 2. Then you go to the second level. You start with your S. Again, your S block, and there's a picture in the book that shows it really nicely. Your S block is here in the periodic table, and you won't see the periodic table on the video. The video ends right here, but you can listen. The P block is going to be on the right side. Remember, it holds a maximum of 6, so 1, 2, 3, 4, 5, 6. Your D block is your transition metals. You can count 10 across.
10.
And then your F is 14, and you can count 14 across. I'm not going to ask you any to go this far. And again, remember that even though you would think this is the 4th energy level, this actually begins with a 3. So we have 29 electrons. We've used 2. We move to the second energy level. So you can see we're equal with about lithium and beryllium. We got 2s2. Move over to our P block. The second energy level holds S and P. P holds a maximum of how many electrons?
6.
6. So we got 1s2, 2s2, 2p6. Now we just hit a noble gas. We hit neon. We move to the next energy level.
3s2.
We have 3s2. That puts us at 12. We have 3p6. That puts us at 18. Then we go to the 4s. Filling it as you normally would, you would put 4s2.
And then you go back to 3D.
And then you go to 3D. And it actually flows just like the periodic table. So here was our first energy level, our second, which had the S and the P, our third, which had the S, the P. This is included in there. You can kind of pretend to shift it up. But if you follow the periodic table straight across to argon, the next one that fills first is going to be your 4s before this D. So then you move to 3D. So far we've used 2, 4, 10, 12, 18, 20. So we have 9 left. So following the usual trend, you would think it was 4s, 2, 3d, 9, and you're done.
Yeah.
But copper is one of the exceptions to the rule. So the actual electron configuration is not this. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s1,